Here are some notes about the z-scores. There's a link right here, as you can see, from Khan Academy about the z-scores. You could click on it and watch the video too, but this is part of the website also about the z-scores. What are z-scores? A z-score measures exactly how many standard deviations above or below the mean a data point is. The formula is you just subtract the given data, like an exam score, minus the mean, the average, divided by the standard deviations. So it's like how many standard deviations the point is away from the mean. In short, with symbols, we write it this way. Z equals x, that's the data point, minus mu, which is the mean, over sigma, which is the standard deviation. Some important facts about the z-scores. A positive z-score means the data point is above average. So if we're looking at scores, and if you have a z equals 1, that means you're away or you're above average. If z equals -1, that means you're below average. If z-score equals 0, that means you are representing the average of the class. A data point can be considered unusual if it's over 3 or away below -3. Most of the data set in the standardized data set goes between 3 and -3. Rarely above 3 or below -3. So you can see the graph right here. The graph is called SND, Standard Normal Distribution. The z-score in the middle is located. Z equals 0 means the average. Z equals 1 means you're above average with 1 standard deviation. Z equals 2, which means positive 2 standard deviations above the mean. It's rare to see numbers above 3, and also rare to see numbers below 3, -3. Z equals -1, that means you are below the average of the class with 1 standard deviation below. That's the meaning of it. Here's the formula enlarged. The score goes for x, mean for mu, and sigma stands for standard deviation. Now, if you notice what's going on right here, the graph in green on the left shows data from a regular data set in a regular situation. When we standardize the data, the 1010, which is the mean, is converted to 0, or is equivalent to 0 as a z-score. 10,030 right here is converted to z-score equals +1. So x equal 10,030 is the same as z equals +1. And that's the meaning of standardizing the standard deviation. It's easier to look at +1, 0, +2, 1.5 compared to 1030, 1010, and so on. So if somebody says I have a score of 1032, you cannot tell what's going on unless if you see the data and you see a graph. But if somebody says I have a z-score of 1.5, you know where they're located. They're located 1.5 z values or standard deviations above the mean. Now, things that you need to know about the normal distribution, the standardized normal distribution. They always have the same shape. As you could see, the mean of any standardized normal distribution is always 0. The standard deviation of any standard normal distribution is 1. So we always have sigma equals to 1. Sigma changes. Sigma in the x's values, we use sigma. When we convert it to z, x becomes z and sigma becomes 1. Now, what's interesting is between one standard deviation above the mean and one standard deviation below the mean, we control percent-wise 68.27% of the data. That's almost like 70%, almost. When we look at 2 standard deviations above and 2 standard deviations below, we control 95.45%. And if we go to 3 standard deviations above and 3 standard deviations below, that controls 99.73%, almost 100. That's why they mentioned that above 3 standard deviations, above z equals 3, it's where to find data. Now, this is another way, or the other way around, to find the x values, the raw score, if you're giving the z-score. So to find the z-score, z equals x minus mu, or x bar, over sigma. So given x and giving the average and giving the standard deviation, that's how you find z. If you want to solve for x and you want to find x, what you do is you put this over 1 and you cross multiply, and this is what we have: z times sigma equals x minus mu times 1. So z times sigma equals x minus mu. And if we add mu to both sides, we end up with x by itself equals z times sigma plus mu. Z times sigma plus mu, or the mean. So if you want it as a formula, that's the formula. If you want to do it in steps, you just take care of it, multiply, cross multiply, and finish it. Here's another resource with some worked examples. Example number 1. The grades on a history midterm at Almond have a mean of mu equals 85. So we are given that mu is 85. The mean is 85. The standard deviation is given to me as 2. Michael scored 86 on the exam. That means x equals 86. Find the z-score. Z is missing. Well, we know the formula. Z equals x minus mu over sigma, which is X was given to me as 86 minus mu, which is given to me as 85, over sigma, which is given to me as 2. So we write 2 right here. And simplifying, we end up with 86 minus 85, that's 1 over 2, which is half. So z is half. That means, looking at the graph, you are somewhere right here, somewhere right here, which is not bad. You're above average, within half standard deviation above. So Michael's z-score is 0.5. His grade was half of a standard deviation above the mean. Next, the grades on a geometry midterm at Almond have a mean of 82. So we are given that mu is 82. The mean is 82. The standard deviation is 4. And the score is 74. Whenever you see score as 74, that's not z, that's an x. So x is given to me now 74. Find the z-score. Z is missing. To do it without using the formula, just like the basic formula, cross multiply, we could do the following. So we have z equals x minus mu over sigma. And now we have mu is 82, that doesn't go here. X is 74, that's gonna go right here. And sigma, which is 4, that's gonna go right here. So we have 74 minus mu, which is 82, over sigma, which is 4, which you could see right here, it agrees. Simplifying 74 minus 82, that's negative 8 over 4, which is negative 2. That means that Michael's z-score is negative 2. His grade was 2 standard deviations below the mean. Graphically, looks like this. So he is way down here, which is not a good sign. So if you look at the graph, this is z equals 0, this is z equals negative 1, and he is located down at negative 2. So if you look at it differently, at negative 2 to positive 2, we are controlling 95.45%. So about 5% goes green right here and right here. Let me show you on the other page. What do I mean? So when you, let's say 95 approximate. I'm converting the 95.45% for the convenience to 95. So if you are looking at the graph this way, between negative 2 and 2, there's a 95% of the scores of the data, and he is located right here. Well, that means to me that this portion and this portion is the rest, which is, you're looking at 100% minus 95%, and that is equal to 5%. 5% divided by 2 is 2.5%, which means this is 2.5%. Let's take this back. This is 2.5%, and this is 2.5%. So Michael is right here. he is holding only 2.5% below him. So another way to look at it, since there's a lot of information right here, as you could see, we are looking at him at -2. We are having 95 plus 2.5%, which is 90, about 95 plus 2, which is 97.2% above him. And we are looking at this portion only below him, which is about 2.5%. Hopefully that helps. Here's the table that we read from z-scores. So if I zoom in right here, you could see at z equals 0%, sorry, z equals 0, you are controlling 0.5. 0.5 reads as percent, which is 50%. All right, this is just one idea. Of course, as you move on, this is z equals, for example, 0.3. 0.3 will hold a little bit more, which is about 62%. And if you go even low, like 0.8, you're controlling about below. Everything is below. Everything is below in this table. Some books they use above, but most books they use the graph below. 0.7881. Notice that this table is all about from z equal 0 and above, positive z-scores. So let's go back. Here's, on the other hand, the left-hand side. Here's the negative z-scores. Well, of course, if you are to the left, for example, if z equals -3%, -3, I mean, it's gonna hold that much. Remember when I said when z equals -3, you don't see much right here? It's actually that much, and that much is 0.13%, less than 1%, or less than 2%, actually. And that's why -3.4, which is extreme, you have only that percent below, 0.0003. 0.0003. As a percent, when you read it as percent, it's 0.03%. All right, I have more details coming, so that's why I'm not spending the whole time on this table. Just to give you an idea about positives and negatives and how do you read from the table. Now, here's a good graph, and the source is on top. You could click on it or type it if you can't. If you look at this right here, the number that they're trying to mention right here, which is 0.9115, as a percent, it reads 91.15%. That's a little bit high. 91% of the data below. So what's the z-score that they're trying to show you? It's coming from 1.3, add this much to it. So z is actually 1.3, add 0.05 to it, that's the 5. So think about 1.3 plus 0.05, that's 1.35. That's how we read it. So if somebody says, what's the percent of the data below 1.35, you read 1.3 from the left and you add the 0.05 moving forward on the top, as you could see. Now, look at the graphs at the bottom side. This is 1.35 is 0.99. Slowing down because this does not agree with this number. It's supposed to be 0.9115. But anyway, if this is true, let's take this for now and keep it. As you can see, it doesn't match the table. If somebody says, what's the percent between z equals 0 and 1.35? Z is greater than or equal to 0, less than or equal to 1.35. P means percent. Well, from 1.35 down, as they are claiming right here, it's 0.99.15. Sorry, 0.9915 if I keep it as a decimal. From 0 down, we know that from 0 down it's 50%. Above 0 is 50%, below 0 is 50%. So let me write it 0.5. So if you subtract 0.9915 minus 0.5, you get 0.4915. You get 0.495, and that's what they're claiming. So this much is about 50%. Next, find the property that a single person, sample size equals 1, gets a test value between 74 and 78. 74 and 78 for their exam score. Assume that the exams are normally distributed. If they're normally distributed, we could use the table with a mean of 85 and the standard deviation of 4. So mean is, I don't know if I said 85, it's 82. The mean is 82, so this is mu. The standard deviation is 4, and we have, let's say, x1 and x2. We have two numbers. We are told that our sample comes from a normal distribution population, which means that we can use the z-table to determine the probabilities, the percentages, or also sometimes called area under the curve. Let's work on this problem. Well, before I start the steps, I'm showing you the graph that helps you understand it. So we have the mean is 82, I keep saying 85, standard deviation is 4, and we want to find the probability between 74 and 78. The idea is convert the 74 to z-score, you'll get -2. Convert the 78 to a z-score, you get -1. So 74 correspond to z equals -2, and 78 is like z equals -1 in this example, as you could see. So all what you need to do is find the area under -1, find the area from the table under -2, and subtract them to find the difference between them, which is graphed right here. So this is what we're doing. Anytime you are asked to find the probability percentage or area under the curve, these all mean the same thing. For a normal distribution, you will use a z-table. The z-table is a table of probabilities for each z-value. A z-value is the number of standardized deviation you are from the mean. To use the z-table, you must first convert, that means standardize. When you convert x's to z's, this is a term that we always use, standardize the values in your question to z values. Here's how. Our first value here is 74. So we have x1, let's call it x1, 74. How many standard deviations from the mean is 74? That's the idea of z. Z is always saying how many standard deviations. If z equals 1, that means you are above the mean by 1 standard deviation. If z equals 2.5, that means you are above the mean by 2.5 standard deviations. Visually, we can see that it is -2. Well, they're saying visually, well, it makes sense. Let's take a look. Z equals x minus mu over sigma. Well, we have 74 and mu was given to me as 82 and sigma is 4 from the page before. As you can see, sigma is 4, the mean is 82, and we're looking at 74 to start with, which is x1. So the question says, how far is 74 from 82? And it's a great concept, but I'll slow down because I don't want to confuse you speaking those terms. How far is 74 away from 82? Well, I know it's to the left of it, but the question does not say how far as in centimeters or kilometers or inches. It's actually how far in units of standard deviations. But the standard deviation is 4. So they're saying how far you are below, because we could see we are below the mean. How far below the mean in terms of, not inches, in terms of sigma, in terms of 4 units. Let me graph it before I do the math. This is what we have, and this is the mean. This is x equals 74, no, sorry, 82. And we have let's call this one x bar, x equals 74. Well, to go down from 82 to 74, let's go down one step. I'm gonna call this step as standard deviation. The standard deviation is 4, so let's go down 4 units. 82 minus 4 will be 78 minus 4. 78 minus 4 again is 74. So how many standard deviations is 74 below 82? The answer is 2. 2 standard deviations below, that's -2. So going back to the steps, we have 74 minus 82, which is -8. How many 4s in -8? It's -2. Hopefully that helps understand what's the idea of this formula. When you divide, you're saying how many. For example, if I say how many 5s into 30, divide 30 by 5, you get 6. The answer 6 means how many 5s into 30. Here we're saying how many 4s, because standard deviation is 4. How many 4s is in the distance between x and mu? It's 2 4s to the left. That's why the answer is -2. Now we do the 78. Well, 78, we are writing the formula again. Z equals x minus mu over sigma, which is 78 minus mu 82. The mean is 82 and sigma is 4. The question is, I know you could subtract and it's already done right here, but let me explain. So if you are here at the mean or mu, and clearly you are at 78. 78 is still to the left of 82. So if this is 82, 78 goes right here. And to go to 78, that's 4 units to the left. So how many segments? How many 4s? You are 1 sigma to the left. That is called z equals -1. So if you do the math, that's -4 over 4, which is -1. That is equivalent to z equals -1. That's the meaning of z. As I said, I showed you the graph earlier because I want you to see that 78 means -1 z values, 74 means -2 z values. You read this from the table reads it all the way to the left. You read this from the table, subtract them to get what's in between right here. They're showing you more detail here. Let's see if this time they have it right. So we are looking at 74 was converted to -2. We are looking at 78 was converted to -1. Under -2 we have 0.1587. Under -1 we have 0.228. Actually the other way around, because under -1 is more than under -2. Let's look at the table. So just keep in mind, we are trying to read below -1 and below -2, and we're going to subtract. This is below -1. -1 and nothing added after the decimal point, so it's 0.1587. You could see it in the box, but for your convenience it's written on top. So below -1 is 0.1587. This is z equals 0. This is z equals -1. And this portion right here is everything below -1 as 0.1587, or differently 15.87% as percent. Now let's read below -2. Below -2 should be a little bit less. Below -2, it's this much, as you could see, because you're reading without anything being added to -2. So at -2, which is farther to the left, we are looking at this right here, and that reads as 0.0228. 0.0228, or about 2.28%. Now let's combine both. If you remember the numbers we have this, and it's right there, 0.1587, Let me go back and see it. 0.1587, yes. And we have this below 74 or below -2 as 0.0228. The difference will be 0.1587 minus 0.0228 equals 0.1359, and that is this right here, which is this right here. Hopefully that helps understand what's the z-score and how to convert back and forth from z-scores to x-scores and the meaning of the z-scores. It's called normal distribution, standardizing, changing x's to z's. The mean becomes z equals 0, and the standard deviation, whatever it is, in this case the standard deviation is 4. That means and the z value becomes z equals 1. Thank you.